Hello everybody, this is Bruce from Groxio Learning and we're back. I've got the dog on the floor and today we're going to be talking about rendering our first little chunk in the live view.
Hey friends, Maggie here with Team Groxio. We are happy to have you joining us on our Tetris series. I'd like to invite you to come on over to Groxio, Grox.io, and you can sign up for our newsletter over there and see what other content we have available for you and get some information about signing up for some training with Bruce Tate himself. We'll see you.
So recall that everything that we've been working on has been part of the back-end system so far. We've had this point, and this point is just the concept of a single one of the squares. And we're going to represent that with an X and Y location. We created this origin, which is a constructor, and then a bunch of reducers that allow us to move our points left, right, and down, as we'll need to in the Tetris game. And there's also this Tetromino, and the Tetromino also has a couple of constructors, one for tests and experimentation, and one that will give us a random shape, and that's the one we'll use in our game. And this also has constructors. This takes a Tetromino and returns a Tetromino, but the Tetromino uses the other reducer. Each reducer here uses other reducers in our code stack. So what we're going to do is just render some raw chunk of that has basically this structure in code form, but that's going to basically allow us to play with things and get a sense for how our program is shaping up and also get a sense for how LiveView works. So this is Phoenix, and we're not going to spend much time in Phoenix channels, controllers, or templates or views. We're going to stay in this LiveView section. This is basically the way that I build a one-page flow. And I'm going to essentially build a work in a renderer, and you can see that these would normally have routes like this with get and post, because these are HTTP verbs, and that's the underlying mechanism that we'll be using. Well, live views work over a socket, and so this is what we're going to be specifying for the type of route. So this is the type of route. This is the path that the user will type to get there. And there might be, this is in template form, so there might be IDs or things like that. Or you might just list out the path directly, and that's what we'll do. This is the name of the live view, and this is the live action. So we're not going to have a live action to start right off, so we're just going to type live, and I want this to go to game, and this is going to be game live. So that's kind of short. We don't need a live action, so that's a good place to start for us. This is going to fail. Actually, I don't even have a server up yet, so I think we're going to be okay. So this would fail because I don't have a game live up yet. Actually, let's go ahead and start the server. That's nice, just like that. So now we have a server running, and I can go to localhost, and we can see that our Phoenix application is working just fine, and we could see that we're working with a live dashboard. That's a new addition. But let's specify the game. And you can see that this is breaking, and it's breaking because we don't have this game live defined yet. So let's go ahead and define that. This is going to go in the live view templates. So we could, for example, grab the top of this plus the mount, because we're going to need that. We'll also need a function called render, but we'll add that in a second. So we'll add a new file, and this is going to be game live.ex. So, and we're going to paste that code in. That's game live. This basically implements a LiveView behavior, and I don't think we need these implementation equals true. What that would do is throw an error if this signature did not match the behavior's signature exactly. So basically we're implementing a contract, and the important elements for us is that this has a mount, and we'll look at the socket a little bit later. This is what we're going to use to track state. So we can put anything that we want in here. So I'm going to put hello world. All right, so that's good enough. And then I'm also going to need to be able to render. So one of the things in this socket is an assigns key. This is just a big old map, and we can put an assigns key in there. So I'm going to take assigns. So those are the variables that we've chosen to work with. And one of the variables, they're just keys in here, is hello. And the value at that key is world. And we could see this by rendering a template. And in LiveView, I can use the LiveView sigil right here. So this is a sigil. Before we worked with the array of words sigil. This is the LiveView sigil. It's one that's custom built for this purpose. And we get it when we import this function. So that means somewhere sitting in our code base is a sigil L function. So now we can use this template and drop in whatever we want to. So let's just drop in the string, something interesting. And let's just wrap this in header tags like that. So that's just straight HTML, and we'll grab a little bit of style to put around this thing. So there's that existing form that we had, and this has like a Phoenix hero. So let's grab that whole shape there, and we'll put this at the top, and then we'll close this out with like that. Okay, so now we have HTML that's being rendered directly in the LiveView, and this should run. Okay. Render 1 was not implemented. Is that not render 1? Oh, okay, so this is Tetris Web Game Live. So let's make sure. I'm going to restart this just to make sure everything's picked up okay. Okay, so I am getting a failure here. So we're running the endpoint, and we terminated. The game failed because render 1 was not implemented for Tetris Game Live. So this is our render function. So I expected that to work. So let's see if we picked up everything that we needed to in here. Yeah, we did. So this makes sure that I have access to the LiveView. Now I want to make sure that my route is correct. So I'm going to go and look at that. So here's the router. So this gives me game and game live. That should work. So I'm going to save this, and now this should work. So if I go to my view and I go to game, you can see that we're showing something interesting. So that's exactly what's in here. So now I'm going to drop in, let's drop in hello. And we can say hello. And then this is going to give me back whatever's in hello. Well, what's in hello? Well, it's world. So let's see if we get that. So I haven't saved this yet, I bet. Yep, I haven't saved it. So now you'll notice this already reloaded for me, and I get hello world. So that's great. But what we'd really like is to start experimenting with the Tetromino that we already have. We want to start to use our reducers. And so one of the things that happens in Tetris is that when you put a shape on the board, it starts falling until it hits the bottom of the board, and then you get a new shape. So let's implement something like that, and then we'll call that good for this particular demo. So I'm going to start a timer here. And this timer is going to use OTP. So let's see. I'm going to go over here and I'm going to go IEX mix, just so we'll have a working version of our application. We'll be able to play with things in IEX as we need to. So there's something called a timer. Yeah, a timer in Erlang. And this allows me to send messages on an interval. And so that's the one that I want to use. And let's see what this looks like. So I'm just going to use help, and that gives me the form that I want. So there's a /2 and a /3. So this is the version that I want to use. It takes a time, and I expect this to be in milliseconds. And it also takes a message for me to send. So let's just send, let's do a timer.send interval. And I'm going to take a time, so let's a half a second or 500 milliseconds. And then I'm just going to send the message tick. So what should happen is this should send an OTP message that I need to pick up here. Now, you don't have to know everything about OTP, but one of the things that happens in OTP is it gives me a template for handling messages that are sent by the framework. So what's going to happen is by sending this, I'm going to be sending messages that my system is not yet ready to handle. So let's see if I don't get a crash here. Yeah, you see this reloading over and over on a half a second interval, and we could actually look at the logs and we could see that yes, we are crashing, which is a great thing. So because we know that something is breaking, and we can look for the shape of the thing that's breaking. So I'm going to look for handle info. Yeah, so this handle info, the game live handle info, doesn't get what it expects. And what does it expect? Well, it looks like it expects a tick and the socket. So we can do that. So and you can see what's in the socket. There's an assigns with all this junk. There's hello world. So let's go ahead and implement a handle info. So def handle info. And we're going to take a tick, and we're going to take a socket. And I don't remember what goes inside here. Well, I actually do, but I just want to illustrate the concept that errors are your friends here, right? And so now we should get another problem. So it expects a specific format to come back. So it said it expects this or something else, and this is the form that we're going to use. So let's go ahead and implement that. So I'm going to just return no reply, I think is what it said, in a socket. And so now this should stop the bleeding. Okay, we're not actually doing anything yet though. So let's look at what's actually happening here. Inside this socket basically is everything that I need for the state of my live view. So if you're watching at home, repeat after me, a socket is the state for a live view. So I'm going to ask you, what's a socket? And you're going to respond, a state for the live view. Everybody, what's a socket? It's the state for a live view. Yes. And so one of the keys in there is assigns. So I can access socket.assigns, and you can see that one of the things in here is hello world. So the first thing that we're going to do is put something more interesting in this socket. So let's actually do this. So I'm going to say socket new game, right? And so the new game, now I have to implement that. Or let's say new. I want to add a new Tetromino to the socket. So the nice thing about shaping things in this way is that as this grows, I can grow this pipeline where each one of these is a reducer over the socket. So I'm going to specify the new Tetromino. Great. And that's going to take a socket. Man, that was horrible. You see that misspelling? I have no idea where that came from. In my head, my fingers were typing perfectly. Okay, so I'm going to say assign socket. I don't want to be typing Tetromino over and over, so I'm just going to say socket tetro. And then I'm going to use my existing model. So remember, we had this reducer for the game, and that was called new random. So we're going to use tetromino.newRandom. So new random, there it is. So now this thing should have the socket, but now this is going to blow up. And what I'd actually like to do instead is render the inspect just that tetro. And this is going to give me code back. So sometimes when I want to format code, HTML pre is excellent for that purpose. So that's going to give me a little preview section, and let's see if that much works. So Tetromino is not available. That's because we didn't alias it yet, right? Remember, we have this idea of alias. So we have to refer to this thing as Tetris.tetromino, but I don't want to do that everywhere, so I'm going to alias. So this allows me to use the shortened form right here, and that's what I'm going to do. And so we can see that we're getting this Tetromino. Okay, so that's progress. That's step one. But now we need to move this down with every tick of the timer. And luckily, we have a function that we've used to move something down. So I'm going to take advantage of it here. I'm going to build another reducer called down. And this is one that operates over my socket, right? We're in a live view called game live. The state for the live view is what? It's the socket, right? So all of my reducers are going to be over sockets. So I'm going to say assign, I'm going to pick out of that socket. I'm going to pick out the assigns. Remember, this is just a map, so that's a key. Actually, it's a struct, which is a map. And then I can look for the Tetromino. The Tetromino, right? And so there's my Tetromino. And so now I can do this. I could say assign is what a socket assign. Well, it returns a new socket with more stuff in it. Right, so I can assign the socket. I want to put in a tetro, the new tetro. And the tetro is, we're going to use, this is down, so we want to use our reducer to move the Tetromino down. Okay, so I said that if we built our code using reducers, Elixir would reward us. And so this is already reloaded and it's already started moving down a little bit. Well, I thought that it would. So what's happening here? Let's find out. Oh, we're not calling our reducer yet. So this needs to call down socket, right? Great. Yeah, so this is already updating, right? And you'll notice that this automatically reloaded. We haven't coded any JavaScript or anything like that. And we're just adding a very small bit of code. So let's see in the inspector exactly what code is being sent down. So I'm just going to control enter and inspect element. In Safari, this is the inspector that I get. And we could actually look at what's moving on the network. So let's go to the network. Yep. And let's see what's happening on that WebSocket. Yeah, so it's sending this Tetromino this whole thing down when our function changes, right? Now, we don't have to move this whole big chunk though. We could just move this tiny little section here, right? So let's do that. Let's say that we want to render the Tetromino. So what I'm going to do here is, this is the inspect tetro. So I don't want to move this whole chunk. So let's actually take this thing and let's render. Let's do it this way. So I'm going to say that the shape is the tetro.shape. And then there's the rotation and location. So rotation is tetro.rotation, in the location and so I'm going to go ahead and grab the X and the Y. And where do I get those? I can get those from okay, so the way it works is if I process code without the equal sign, it's just going to process the code there. And so here I've bound a couple of variables, X and Y. And so for the location, now I can just drop in line the X and the Y. So let's see what happens now when we look at the network traffic that's actually moving in our application. It should be substantially smaller. Yeah, you can see, look at that. Here's one of the little diffs. All I'm doing is saying, hey, go down to a specific place in the DOM and shove in a 15 or a 38, 39, on and on and on, right? So that's really cool. It's only sending down one number, even though I've dropped in all this other stuff, which is great. So and I need to inspect this, don't I? Inspect tetro.shape and inspect. Let's see if that works. So the shape and the location, yeah. So so basically, I'm getting exactly what I need to from the Tetromino, right? So let's find out why these elements right here are not being populated. So we can actually look at this element, inspect the element, and we can see the shape. There's nothing over there, right? So something is wrong with what we're doing here. So, oh, yep, and you can see we didn't put the equal sign there, right? Yeah, so this is a Z shape. The rotation is 0. And so that's set. But if I look at the network and look at exactly what I'm sending down, it's sending down very little data here in the WebSocket here. Just a tiny amount. That's really amazing to me. Okay, so what have we learned so far? We've learned that a LiveView is a real-time flow that uses JavaScript on the back end, but we don't have to write any of that JavaScript ourselves. And we've also learned the shape of how a LiveView works. It has a mount, and the mount sets up the initial data for a LiveView in the socket. And then we have a render, and the render happens anytime that you change the socket. So it'll render initially after mount, and then it will also render after any change that you make to the socket. And so that's one dimension So we have the assigns and the render, the socket and the render, the state of the live view, and we render it. And the second dimension is that we have these inbound messages, and the inbound messages can change the shape of the socket. So events change the socket, sockets trigger a render, which is a beautiful way to design an API. So when we come back, we'll start to render not just the X's and the Y's, but we'll start to render graphics, so you'll be able to see the points move. What's happening right now is we are dropping our point, and right now it looks like it's going all the way down from the United States to I guess China or whoever else is right on the other side of the planet from us. So we want to stop this at 20, and we'll just make it go ahead and restart. So those are a couple of problems that we'll solve next time. We'll kind of stay in live view land for a little while, enough to render our canvas, and then we'll break back into our model and start to render some of the special shapes and see how far we can get with that. So this is Bruce and the dog on the floor for Groxio Learning. Hope you've enjoyed this video.